Hello and welcome to an FPGA vision video. In this channel I have several FPGA designs for image processing which are a bit more advanced. And people were sometimes asking about a more beginner suited example. And yes, here it is. So what we will look at in this video is a VHDL design for beginner. We will do a video generator and write it in VHDL, implement it on an FPGA. And you can use our remote lab, or you can use such an FPGA board, which is available at moderate cost. If you want to start with VHDL, you might want to look at a good book to read. There are several books out there. One free book, which I can recommend, is on GitHub. The book is Free Range VHDL, and there's source code there, but you don't have to compile it. If you scroll down, there is a PDF version. The design that I want to introduce to you is a video generator. And in order to understand a video generator, we first need to look how a video signal is composed. And the VHDL design is relatively easy. But before we can go to that, we have to have a little bit theory to understand the video signal, to understand what the FPGA is doing. So let's have a look at a video signal. A video signal is made up of different frames, and each frame is displayed line by line. Beside the image information, the active video, there is also an inactive area, a blanking area. A blanking area for the frame, so on top and below the active image, and an inactive area in the line, so to the left and to the right of the image. And we have control signals to indicate where we have a frame and where we have the lines and where we have the active part of the image. In our example, we use a 720p video signal. 720p is 1280 pixels per line, 720 pixel lines, and 60 Hz refresh rate. The vertical blanking is 30 lines, making a total of 750 lines, and the horizontal blanking is 370 pixels, giving a total of 1650 pixels. If you multiply these values, so 60 frames per second, 750 lines, 1650 pixels, you get a clock speed of 74.25 megahertz. So with every clock cycle, you give out one pixel. Pixel could be an active pixel of the active image or could be of the blanking. And to indicate where the active pixels are, there are three control signals. You have vertical sync. This indicates the start of the image. Horizontal sync to indicate the start of a line. And data enable to indicate active pixel. Data enable is active for 1280 clock cycles. And during this data enable, one output line is given to the output. This signaling is redundant, so you could only use HSVS or only DE, but it's historical from the control of CRT monitors. So you have 60 frames per second. This means one frame is 1/60th of a second. The output is RGB, red, green, blue, and these are three color channels with 8 bits each. And each color channel has a color component, has a value between 0 and 255. So 1 byte for each color component. Now we zoom in a little bit to the timing. So in one clock cycle, we have 1 pixel. Here we have the start of the line, data enable becomes 1. And then we have red, green, blue for the first pixel in the line, for the second pixel in the line, for the third pixel in the line, and so on. And the value for red, green, blue indicates if this color content is present, partially present, or not present. So you get different colors by having the different color components with a certain intensity. Let's have a look how that works. So we have a color coding RGB, and here on the right side you see some color combinations. So red, green, blue, if you only have the red component 255 and the others are 0, we get red. Same for green and blue, these are the primary colors. Then you can combine red and green to have yellow, red and blue to have magenta, or green and blue for cyan. Other combinations are also possible. So if everything is 0, that's black. If everything is 255 full intensity, that's white. And if everything is in the middle, 128, this is gray. And you can also have other combinations. If you want to find out how the value of a component is, you can use image editing programs. For example, Irfan View. This is displayed here. If you have Irfan View and you press the left mouse button, you get the color information here in the status line. So here are also examples: 196, 213, 243 is this gray-blue color from the sky. And these are two other colors that are indicated by these numbers. Okay, now with this brief introduction to video signals, we can now design a generator for video signals. We will do this in the next video, where we look at VHDL design. Then we have a video on VHDL simulation for verification and 2 videos for implementation. One for implementation on our remote lab and another one for implementation on a circuit board.